Hey guys, for this week's mini lecture, I'm going to focus on hemoglobin because I think it is a little bit underrepresented in your book. So hemoglobin, what it is, it's a heterotetramer, and what that means is that there are 4 subunits and they are not all the same. So monomers, as you guys probably remember from last time, you'll have a peptide, and that'll come together to form kind of like a big globular protein looking thing. So this is your tertiary structure. Proteins also have quaternary structures. So for the case of hemoglobin is you're going to have, and I'm just going to, instead of drawing it as a big squiggly thing, I'm just going to make it a circle, a combination of 4 monomers. And these monomers aren't actually all the same. You'll have an alpha monomer, 2 alphas, and 2 beta monomers, and that's what makes it a heterotetramer versus a homotetramer, which would be where they are all alphas. So with these 4 subunits, the way that they come together, there's 2 different ways that they can come together. Oh, sorry. So other thing you need to know is that you also have heme, which is, I'm not going to completely draw it out, but essentially you have a structure within each of these proteins that has an iron, and this iron can bind oxygen. So I'm just going to draw iron to represent it. Each one of these has an iron site. So hemoglobin can bind up to 4 oxygens. There's 2 different states that the heterotetramer takes. You can either have the R state or the T state. And essentially, I'm just going to draw the irons. There's 3 different things you can have in the R state. But really all you need is 1 bound oxygen. So I'm going to put these other ones in parentheses. Versus the T state, which is where you have just all empty irons here. The majority of the time, your body is in this R state here. Oxygen, it's actually a lot easier to bind these oxygens when you're in the R state than it is when you're in the T state. So the only time you're ever really in a T state is when you're like working out really hard and you get exhausted. And that's when you enter this state here. As I said, or hopefully I said, it's a lot harder to bind oxygen here. So when you hit that point of exhaustion, that's the point where you've started to lose that last oxygen off of your hemoglobin, and now you're in this T state here. And once you're in this T state, it's so much harder to put oxygen back on. So then when you're like running a marathon or whatever, and you just feel like you can't, you're gasping for air, you've hit the point where your hemoglobins have become this T state hemoglobin versus your R state hemoglobin, where you can kind of easily breathe in, get more oxygen, and then breathe out to release it or release carbon dioxide. As opposed to where you're in the T state, you're gasping for air and it doesn't seem to be doing anything. Because it literally isn't doing anything, because it's harder for you to bind oxygen at that point. The other thing that I wanted to talk about was the kind of this pH effect on binding. So one of the things that you never really think about is when you breathe in, your red blood cells bind oxygen, and then when they get to the tissues, they release oxygen. And there's no real, a lot of the time, there's no real explanation as to why it chooses to release there versus releasing earlier along the path versus just releasing while it's still in the lung stage. And one of the main things that is contributing to this is pH. So at a higher pH, like in the lungs, you bind oxygen tighter. So when you're first in the lungs and you're breathing in, you're at a state or a pH where you're actively binding oxygen. And then when you get to the tissues, the pH is lower. So I have that drawn over here. You drop down to 7.2. And at this point, your body wants to release because it's at that lower pH, so it'll actively release oxygen. The reason that you don't release it in the blood on the way there, so if you think about it, the amount of oxygen that's in your tissues is very low, and the amount of oxygen that's in your lungs is high, because that's where you're breathing it in. Tissues is where you're releasing it. But there's also no oxygen in your blood, for the most part, except for the ones that are bound to your heme. So the reason that it doesn't get released during the process of transporting from the lungs to the tissues is that the blood pH is actually even higher than the lung pH. So your blood pH is all the way up to 6.2 here. Or 6.4. 7.6. Sorry. I've probably been saying the wrong number this whole time. Go with what I wrote, not what I said. And that is why when you breathe in, it actually brings it to the tissues, as opposed to just releasing it wildly as you go on. Okay, there's a little bit in your book which talks about CO2, which helps to make the tissues more acidic, but I will leave that up to you guys because that's part of your end of the chapter assignment. If you guys have any questions, please send me an email, and I hope this helps.